This lesson is on how square roots and squares are related. So we're going to start out with defining a few things. So as review, we know that a square is created, I guess, by multiplying a number by itself. So a square is created by multiplying a number by itself. Now in the next unit, or the last unit, we talked about exponents. So we know that to take the square of something, we are using the exponent 2. Okay, so we're raising something to the second power, raising it by the exponent 2. Now, a perfect square, you guys have been using flashcards to practice perfect squares. Perfect squares are a whole number multiplied by itself. So we have a perfect square is a whole number multiplied by itself. And the result is going to be another whole number. So a perfect square, we talked about 2 times 2. We had 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on and so forth. So we're taking those numbers and just multiplying them together. Those are your perfect squares. So you've been practicing them all the way up to 25. Now the new part today is what a square root is. So the square root is the opposite of squaring something. So the perfect square is using the exponent of 2. The square root is the inverse or the opposite, much like multiplication and division are opposites, addition and subtraction are opposites, squares and square roots are opposites. So it's the opposite of squaring something. Now we use a symbol for a square root, and many of you know what it is already. It is a symbol that looks like this. And that symbol is called a radical sign. So when we say the word radical, it means a number that is under this symbol or this square root. Okay, so that's a radical sign. So we're going to make a chart side by side with showing you how it is different. So if we have squares on one side and square roots on the other, let's see how they are different. Okay, so let me push up my notes a little bit. So we're going to use the example of 4. So if we have 4 squared, we know that that is the same thing as 4 times 4, which is 16. Now to do the opposite of that, we would have the square root of 16, which is the same thing as the square root of 4 times 4. Do you see how I can separate it out? I know that 16 is 4 times 4, so I can separate it underneath that radical symbol as well. Now, to come out of the radical symbol, you have to have at least two of them. And I have 2 4s, so when I take the square root, my answer, when it comes out of the radical, is just one of the 4s. That's the undoing part of it. We're undoing the square. So now instead of twins under there, 2, it becomes 1 when it crosses that line and comes out of that radical. Now, you can do the same thing with negatives. So if we had -4 squared, remember I have to put that in parentheses because that negative has to be squared too. This is the same thing as -4 times -4, which is also 16. So what that tells us is the square root of 16 can be positive 4s under the radical sign, but it also can be -4 times -4, because when you multiply those negatives, it becomes a positive 16. Now, if I want to take that pair out from underneath that radical sign, it becomes 1 just like before. So my answer to the square root of 16 is going to be 4 or -4. So it's always going to have 2 options there. So the square root of 16 can be plus or minus 4. Now, most of the time, you only see the positive version of that. So most of the time, it's written as a whole number. So if you have a problem that asks you to find the whole number estimate of the square root, the whole number answer, remember, whole numbers are not negatives, integers are negatives, so it would just be a positive 4. So a lot of times, people just say the positive version and not the negative, but just know that there are 2 of those. If your question asks you just what are the possible roots, then it would be both of them. So some of your answers may include both, some may just be the positive one, depending on how they are worded. So that is the basis of all the beginnings of the squares and square roots, but we're going to do a couple problems with substitution. So let's say we had an equation, y equals the square root of x plus 6, and they give you that x is equal to 81, and they want you to solve for y. What you can do, since we know x is equal to 81, we can substitute that 81. We know x is equal to 81, so we're going to substitute it in for the x. And you guys have done substitution before, so you know how to do this. So when I substitute it in, it becomes y equals the square root of 81 plus 6. Now you've been practicing, so you know that 9 times 9 is 81. So the square root of 81 is 9. We're going to use the positives today, plus 6. Okay, so y is equal to 9 plus 6. So y is equal to 15. Now, if you were looking at the square root of 81 and saying, really, the square root of 81 could be plus or minus -9. We could also have a -9 here, so that would be a different problem. We would have y is equal to -9 plus 6. So y is equal to -3. So in this problem, we actually have 2 answers. It could be 15 or it could be -3. So just be aware that there's a positive answer and then there's a negative answer when you put in your negative answer to the square root. Another problem that I want you to see today, it's our last problem for today, is an area problem. So let's say we have a square So we're working with squares. And we know that the area of this square is 225 units. Now, if we want to find the side lengths, what we know about a square is that the lengths are the same. So if this length is x, this length here is also x. And we multiply them together to get our area. So we can write an equation. X times x is equal to 225. Now, when we multiply these, how many x's do we have? We have 2. So we have 2x equals 2. Oops, I did that wrong. We don't have 2 x's. We have x squared because we're multiplying it. Oops, don't make that mistake. So we have x squared equals 225. Now, if we have x squared, we want to undo that. So to undo that, we have to do the inverse or the opposite. Now, the opposite of squaring something is a square root. So I wish I wouldn't have made the mistake there, so it would be pretty here. But we're going to take the square root of x squared, and we have to do the other side as well because it's equal to it. So we're going to take the square root of 225 on this side. So now we're left with x because the square root, this square root and the square cancel each other out, just like when we're doing equations and multiplication cancels out division or addition cancels out subtraction. We're left with x is equal to the square root of 225. If you've been practicing, you know that that is 15. Now in this case, we're talking area and lengths cannot be negative, so it has to be positive. So this one only has one answer, and our answer is 15 units. Because 15 times 15 would give us 225.